Hello, my name is Darren Thomas. I'm the Director of Educational Research Techniques. This is Easier, Practical Application of Machine Learning Algorithms in R. And so we are now in Unit 3, Lesson 3, and we're doing our model development classification for random forest. And so like you've learned, we prepared the data, and you know that random forest involves making multiple, maybe even several hundred, decision trees, aggregating the results to find out what's the best possible answer. So let's go ahead and move over to RStudio and see what's happening. So my code here is in the upper top. You set your seed to 10. This way you get the same results that I'm getting. And then in lines 2 to 4, we have the actual code for developing our model. So we're going to call it Model 1. Let me zoom in, give you a better view here. Model 1. And you can see right here that our dependent variable is private, whether the college is private or public. We're trying to predict that using the college data set. And so these are the variables we chose to use: grad rate, out of state, yes or no, room and board cost, books cost, PhD, percentage of PhDs, student to faculty ratio, and expenses. And so the data set is called training set. The method is RF, that stands for random forest. And approximation equal true, that means we want the estimates, if you will. And of course, all this is inside the train function. Now, what we're gonna do now is, what you would need to do is you would need to run lines 2 through 4. It takes a few moments. And so to save time, I ran it before the video, and here's the results in line 5 if you just press Control Enter once you're done. And so you can see down here, we have our results here. And so the parameter that we're tuning this time is mtry. That's the number of variables that the model uses each time that it makes a model. Okay, that's what it is. Randomly sampled as candidates for each part of the tree. So in this particular example, the mtry was 4. So it would randomly pick up to 4 different, it would consider 4 variables at a time for each part of the tree. That's kind of what's happening there. And you can see that the accuracy is 90.7%, which is fairly reasonable, and the kappa is 0.76, which is very good for a kappa in this particular context. So it looks like we're doing a reasonably good job discriminating between whether something is a public or a private university based on the variables that we're using in this study. Now, the next thing you're going to see here is something called the variance importance. The variable importance. This is in line 6, the var imp function, and it tells you how important that variable was in being used to separate the private and public universities from each other, or the categories in your categorical dependent variable, if you will. So you can clearly see that out of state was most important, followed by student faculty ratio and percentage of PhDs. In other words, the main difference between a public and a private university involves these 3 things: whether the student is from out of state, the student faculty ratio, and the percentage of PhDs. The other variables were important, but you can see there's a huge drop off after that. Now in line 7, you have the plot. You can plot this as well, and if you look off to your right, you can see the values are right here. I'll make this a little bit bigger for you so that you can see it. And so you can see right here, this is just a visual we were just talking about. So you can see that out of state goes way over here to 100, followed by student faculty ratio, PhD, all those things like that. Again, not that exciting, not that amazing, but critical for our purposes here. And that is essentially all that needs to be done when you're trying to develop a model. So what's going to happen in the next video is we are going to test the model and conclude our understanding of random forests when we are trying to do classification. Now, one other thing I need to mention before I conclude this video is that you can adjust the parameter here, the mtry parameter. So you might want to say it went from 2, 4 to 7. You might want to try 3, 5, or 6. There are ways to do that. They're kind of beyond the purpose of this course and videos, but it is possible to adjust these hyperparameters, and different algorithms have different hyperparameters that can be adjusted so that you can find little ways to tweak and improve your score. However, you always have to be aware of that over tweaking can lead to overfitting. So that's something else you have to balance as well. Considering the context, this is actually a very reasonably accurate model when you're already at 91%. Of course, context determines how accurate is satisfying when you're dealing with data science and machine learning. So My name is Darren Thomas. I'm the Director of Education and Research Techniques. This is Easier, Practical Applications of Machine Learning Algorithms in R. Take care.